Okay, so in this problem, we are being given the longest turbulent subarray. So what we have to do is there is an array being given to us, which may have like elements and which will have elements, and these elements must alter for every these elements should relate to each other through alternating signs. Meaning, if first two elements have this relationship, then other two elements should have lesser relationship, and then greater, and so on. So in this example, they have explained that same thing, that if suppose the zeroth I0 and I1 elements have a less than relationship, then first and second relationship should have a decreasing relationship. Meaning, if 0 and 1 have an increasing relationship, then 1 and 2 must have decreasing relationship, and then 2 and 3 must have increasing, and so on. And if suppose 0 and 1 have a decreasing relationship, then 1 and 2 must have an increasing relationship, and so on. So how can we solve this problem? Well, here we will have to maintain the state. So let's check this thing out. See, one is we will associate, see, one option is that if suppose I'm standing on one particular element and I have to determine whether the chain has been honored or not. So for every element I might have to traverse back and see, okay, if between these two elements there is an increasing relationship, then I have to see whether the relationship was toggling alternatively or not. So that is one option, but that's a very bad idea because it will lead us to O of n square complexity, right? So that is strongly discouraged. So in order to do this in a linear fashion in a O of n complexity, what we can do is we can maintain a state variable with every element. So with state variable, what I mean is we can have a Boolean variable that will tell whether it was an increasing or a decreasing with respect to the previous element. So that state variable will tell what this element thinks about itself compared to its past. And another variable that we can add would be the value of chain length the value of chain length that it saw from its behind, right? So I'll just explain what this means. So suppose I'm standing at this particular element and relationship is an increasing relationship. So what it will do is it will refer to the variable of the previous element and see what this guy thinks about itself. So if suppose there is an increasing relationship, then this guy should think that it's a decreasing element. Only then the chain would be valid. So if it's a decreasing element, then what this element will do is it will read the value of the chain length that was found till this particular point, do a +1 to it and append it to itself and mark itself as increasing, right? And so this way what will happen is that criteria that prior to this should be a decreasing sign will be valid then. So let's do this exercise for next element. Suppose I'm at this particular element. Now what this element will do is it will check what is the sign prior to this. So suppose the sign is decreasing sign. So then this element knows that I'm a decreasing element. So it will mark itself decreasing first of all. And after marking itself as decreasing, because this element thinks that it's a decreasing element compared to its past. So, and now what it will do is it will check the state of the previous element. So it will find that, okay, the state sign is increasing, meaning this prior element was an increasing element. So then it can safely read the value of this variable, do a +1 to it and update and store the updated value with itself. So if prior to this, the value was suppose X, then it will store the value X +1 with itself. Now let's take this example a bit further. I come at this element now. This element will compare itself to the past and suppose it finds that it's an increasing element. So if it is an increasing element, it will first of all mark itself as I. Then it will go and check the state that what does the previous element think about itself. So it finds that, okay, the element was decreasing element and current element is an increasing element. So meaning the state has been very well maintained, meaning chain is a valid chain. So now this element can safely read the past value and do a +1 to it and store the current value. So it will keep the value X +2, right? But now let us assume that the next element where I come now checks the sign and finds that it's an increasing element. So it will mark itself as I. But now after having marked I, it will check the state of the previous element. But over here, it will see that the state that this previous element should have been a decreasing element, should have a D flag, but has got an I flag, which means that now the chain has become invalid at this point. So now it will have to reject the value of this variable and store a new value 1 for itself, because the next element to this should have an alternating state. Now when it has an altered state and chain has started from this point, so now this has become the first node of that new chain. So since it's the first node, it will have to disregard all the past values that were maintained so far and keep a new value as 1, and then depend upon the next element to decide the fate of this entire chain. So this is the basic idea of alternating the flags. And another thing that we do is at every stage when I'm recording the size, I have to store that value inside a max variable. Like I have to store like this: result is equal to max of result is equal to max of result comma X +2 at this stage, because this current variable is X +2. So whatever variable we'll use to denote this thing, that variable will fill up this place. Because thing is that chain can break at any stage. Suppose chain breaks over here, then whatever the longest value was determined till this point, that should go into the result. And if suppose a new chain starts from here and turns out to be even longer than the past one, so this older value will be rejected and new value would be selected. So that's the basic idea of maintaining the states. Now what we can do is we can do an optimization on top of it. Instead of holding a separate array for states, what we can do is we can rather maintain just two variables called ins increasing and decreasing. We can just maintain these two variables, because if you notice what's happening is once I am at this stage and I have established my relationship with the previous element, this value becomes useless for me now, because now whatever value I hold with myself, that is important, and that is what the next element would look up, right? So we don't need to maintain the state for all the historic elements. So what we can do is we can just need two variables. One will hold the value. Okay, we can just maintain two variables and they will do that. They will do the entire management of these signs in such a way that one value would be valid and other value would be invalid. That's how they will alter. So let's try to do a dry run with this. So if I have suppose these same elements as before, what we can do is, like, if suppose I'm standing on the first element over here, then clearly this guy knows that this is the starting point of the chain. So initial value at the start of the program would be incr1 decr1. So both values would be 1. Here I'm storing increasing values and here I'm storing the decreasing values. So both will be equal to 1 because it's the starting point of the chain. Suppose the value is the first relationship is an increasing relationship. So when the control is at this particular element, it will check the sign. Okay, there's an increasing relationship. So earlier what it used to do was it used to check the previous state as decreasing, right? So it will go to the decreasing sign. It will check, since it's an increasing relationship, it used to check the flag and there should be a D flag before this. So what it will do is it will check this D flag and see the value is 1. So this value it can carry forward and add to itself. So it will keep the value 2. But against what variable? Now this is an increasing, it will mark itself as increasing. So in its I variable, it can update the I variable to 1. It can update the I variable to the new length 2. So now earlier it used to mark itself as I in a separate variable. Now what it has done is it has straight away updated the I variable with the value 2, which is the correct value, which is the accurate value, valid value, and the D variable, which it is not, it will invalidate this D variable with the value 1. Because now if I have a new chain starting from this point, which is again, suppose there is a decreasing relationship, then that value can refer to this invalid value, and then this valid value would nothing else but just be the starting value of this new chain, which is the one single element number 1, and then increase thereon, right? So then if it suppose it comes to the next variable and here it finds that suppose there is a decreasing relationship. So what it will do is it will mark itself as D. So in D variable, it will update the valid value and it will check the state of the previous element. So previous element should have been an increasing element. So it will refer to the I value of it and do a +1 to it now. So this value will become 3. And now since it's a decreasing element, it will invalidate the current state to 1, meaning it is no longer an increasing element. It will invalidate this value as 1. Now if we move to the next element and again we see there is a decreasing relationship. So what will happen in this case is, since this is decreasing, what it will refer to is it will think that, okay, for previous element I should look at the increasing value. So it will mark itself as decreasing. It will mark itself as decreasing, and since it's decreasing, it will expect the previous element to be increasing. So it will check the increasing flag for it. So since increasing flag holds just the value 1, so it will refer to this value and reject this value. So for I, it will take this value and take it 1 plus 1, which is equal to 2. And since this was a decreasing element, it will set its increasing variable to a default value of 1. So like this is how, instead of maintaining an array, we have just used these two variables to like solve this problem, and we'll be doing max of I comma D at every stage and compare it with, sorry, not just max, we'll do result is equal to max of result comma and then again the max of I comma D. So this will tell us whatever is the longest chain till that particular point, and once we reach the end, we know the answer. In the code also we are doing the same thing, that if suppose the relationship is in this case the relationship is a decreasing relationship, since it's a decreasing relationship, so this guy will look at the increasing state of the previous variable and use that as a reference and update its decreasing variable and reset its increasing value to 1, because this is a decreasing element. So for me, the increasing flag should be invalid now. And if there is a increasing relationship, then it will refer to the previous decreasing value and update accordingly. And if there is an equal value, then the chain has become totally invalid. Both increasing and decreasing states should be set to 1. And going forward, it would be a brand new start for the chain.